Hello, my name is Doug Fills, and this screencast is a brief overview of open core data done as a status update for the CSDCO November 2016 Science meeting in DC. Just to give you a quick overview or outline of what this screencast will cover, we'll be looking at a brief overview of open core data, then discussing a little bit about the data flow, focusing a lot on the data flow into the system, and then talking about the data flow out of the system, the access and use of the material or the holdings of open core by humans and by machines, and also discuss a little bit about kind of domain-specific data partners and access to subsets of the data that open core deals with on behalf of the facilities. So let's go ahead and get started. As a quick overview, open core data really acts as kind of a value add to material coming from two facilities. This would be the Continental Scientific Drilling Coordinating Office and the JOIDES Resolution Science Operator Office. So these would be focusing on the continental and ocean scientific drilling efforts funded by the National Science Foundation. Additionally, open core works closely with AIDA and others for the incorporation of unique identifiers and value-add material like IGSNs, DOIs, and also to address other aspects like long-term archiving of data for the facilities. Open core is not an archive. We work with groups like AIDA to address that. So information is being generated at the facilities, and then open core data is either working directly with that raw information or metadata for that information, and then trying to align it across the water line in this case, right, for the continental and ocean drilling communities, and then provide a common mechanism for access to that, both by humans and machines. So a little bit more in terms of the detail of that data flow then, right? So as the facilities are generating the information, the data, there is an ingestion process, right? A kind of a classical ETL, extract, translate, and load process. But during that process, we're really trying to focus heavily on things like semantics, trying to align concepts of measurements and parameters and descriptions of those parameters so that those can be both mechanisms to search on, but also mechanisms to discover data, pivot across data, and associate information coming from these two facilities that are involved with open core at this time. Additionally, during that process, then we're looking to provide additional context through the use of persistent identifiers, right? Whether this be the assignment of DOIs to data sets being generated to that to facilitate citation of that information. It could also, and does also scope in things like sample identifiers through the IGSNs to allow that kind of network of samples to continue to expand. And also, where possible, we're bringing in other identifiers such as ORCIDs or identifiers for facilities or organizations. So that process then, that kind of semantic enhancement, that persistent identifier enhancement is part of the value add then that open core provides and allows then one to move across the data, to link out from that data to things like samples and publications and other information associated with that data. Locally then, we have kind of a polyglot persistent approach to things, and so we have relational databases where necessary and where appropriate. We also have document store databases like MongoDB for things like core imagery, thin sections, PDFs, and other large kind of blob binary type data. And then the semantic information, a lot of the information that we use to kind of interconnect these resources is done in RDF, and of course then is in our graph store. Once we have that information in those storage layers, in that data layer, then we want to begin the process of exposing that, right? And so this is where things like our REST services come into play. Our REST APIs are described using the Swagger documentation approach to allow easy discoverability, the generation of clients, and really just trying to, again, follow as best we can industry best practices in terms of API development. We also follow linked open data approaches and classical web approaches, right? So just the follow your nose discovery on the page, forms-driven interfaces where necessary to provide that kind of familiar environment for accessing information. But underneath that, then, providing that full semantic linked open data capacity with the utilization of things like schema.org dataset or CSV for the web metadata injected directly into the pages. We also do free text searching, so we have a mechanism by which we can index the contents of files, whether they be Excel or PDF or even OCRing the images, and also then just direct access to bulk amounts of data for people who want to download easily large amounts of that data. And then as we reach the top of this diagram, you begin to see then the connection to external sources, right? This idea that tools can come in and utilize it, or people can download the data sets and incorporate them into their existing workflows, whether those be Excel, whether they be things like Jupyter Notebooks or R or things like that, or accessed by direct applications as well. So just a little more detail on getting the data in. As I mentioned, we are using mechanisms to free text index where appropriate certain documents. These are like image documents looking for text in the images, PDFs, Word documents, Excel documents, and we're using the Apache Tika package to perform that operation. We then run that through a stop words library to remove extraneous words that are of not real consequence in terms of searching. We are also extracting data directly from the Janus database. So we have a copy of the Janus relational database, and we have built queries into that facilitate then the development of the data sets, and those data sets then are stored in our persistence layer and can be provided with DOIs for citation and elements like that. And there are other bits of information then that we can extract in, whether they be things like Excel spreadsheets or other things that provide additional context to things like expeditions or projects or things like that facilities are using, and then interconnecting those using the persistent IDs and the semantic approaches that were mentioned. So we have this whole process, this whole ingest process to kind of align that information inside open core data and make it easily accessible downstream. And so that downstream data access, as we mentioned, is driven kind of through your classical APIs. In our case, additionally, a Sparkle endpoint, just because of our utilization of the semantic approaches and a triple store behind the scenes along with this. Linked open data sits on top of that, so our sites can be easily indexed by things like Google or Bing or anyone else who wishes to come through and scrape for machine-readable structured content within those pages. Additionally, we're working with groups like Flyover Country and Gplates and others to really kind of get an understanding of how those applications can best utilize this information. What are the routes to getting the information to them as a mechanism of further refining this wide array of vectors into the open core data holdings. With regards to the human workflow, as we see things like Jupyter Notebooks and R and other things becoming more and more popular, we wanted to make sure that we allowed a mechanism that was easy to use in those environments to get data in bulk out of open core data and into things like the data frames and other approaches that are being utilized in those notebooks. We also wanted to make sure, though, that we provided information using kind of the classical CSV document approach, so that people could feed that information into Excel worksheets or other workflows that they've been honing over a long period of time. So this kind of, addressing many mechanisms for the access and the formatting of this information. Additionally, because we have the semantics and because we have the persistent identifiers in particular, whether they be the DOIs for the data sets or the DOIs that we can associate those data sets back to, things like the scientific prospectuses and things like that, or the IGSNs, we want to make sure that we provide that information to the user. So this enables better citation of that information and a better understanding of the provenance of that information, so that when a researcher is seeing that information in their notebook or in their Excel spreadsheet or wherever it is they're working with it, he or she can easily get access to the bits of data in there that take them back to the canonical source of that data, the authoritative source of that data. So they can roll back to the facilities and say, this is what I got vis-a-vis these mechanisms, and I have questions about it, or I'd like to see other related information about it. So we want to make sure that that's there for proper citation and also for proper provenance. Expanding a little bit on the machine access to the data. So data sets have landing pages, and those landing pages then contain underlying schema.org data set as well as CSV for the web JSON LD metadata. So in fact, both of those metadata approaches are using JSON LD embedded into the actual web page so that when the site is crawled, that information can be extracted and associated with that particular resource in that particular page. Also, obviously, then we provide a Sparkle type access, and then just the classical linked open data mechanisms for crawling through related resources and extracting either the resource itself or the metadata associated with that. All of this then is also mirrored in the API calls, right? So we try to utilize both the Sparkle and API calls for all the user interface, all the user experience front ends that you would see with OpenCore. And so then those same APIs and those same endpoints are available to anyone else to utilize to extract the information for their own use. One of the things that we're working with the CSDCO datasets is that we actually have an application, a package, OCDFX in this case we call it. And all this material, all the source code is available on at GitHub at github.com/opencoredata. And this application can sit on top of the file holdings for CSDCO and then allow us to search the metadata as well as the free text index of those documents, and then reach back in and extract that file for a user to access. And it's a model then that allows us to look at some of the things we're on task to do in the future, which is how do we better integrate data across multiple sites and be aware of what the flow of information is to those sites. So a big focus on machine access to the information hosted at OpenCore Data. Then just to expand on that last point, and that is that one of the things that we're really interested in doing at OpenCore Data is allowing kind of domain vertical or domain specific data services access to information within OpenCore. And so by that I mean groups like Neotoma or MAGIC, the Magnetics Information Consortium, may be looking to gain access to this information, but only a specific domain or a specific vertical of that information. And we want to make that one easier for them to do so they can incorporate into their local data models and enhance their experience for their community. But additionally then through these open data approaches, persistent identifiers, provenance, we want to ensure that the data that flows down to those providers contains the information necessary for them to present to their users so that those users know where that information comes from and they can track back up through that chain of provenance to get to the canonical source of that information. And so this is one of the things that we're really focused on right now and exploring how we can better provide the information out to the partners as well as flow that information back and also be aware of when updates to data, where new data arrives in OpenCore Data, and to make them aware of the fact that they may not have that information, and then they can decide whether that information is relevant and reincorporate into their local data model. So that two-way connection. And that's very important, again, as I mentioned, for things like citation and other things. So that is a very quick whirlwind overview of OpenCore Data, talking about the flow of data into the system, the enhancement of that data through semantics, persistence identifiers, provenance, and other approaches, and then the distribution of that information on the other end to human consumers, to machine consumers, and to interested party consumers like Neotoma or Magic or Flyover Country or other apps that may have an interest in specific parts of the holdings at OpenCore. If you have any questions, please feel free to get in touch with me, and I appreciate your time.